Okay, let's continue our discussion on elasticity. So basically, we talk about the definition of elasticity, and we discussed what factors could affect the price elasticity of demand during the last class. So today's class, first let's talk about how total revenue and the price elasticity are related. So first, we define total revenue. Well, this is a very easy to understand definition, right? So basically, let's say if you sell 10 apples and the price of the apple is $2, then obviously the total revenue is $20. So basically, you can see that total revenue can be defined by, So basically, you can see that total revenue can be defined by price P times quantity, right? So after defining total revenue, now our question is how this quantity, how this total revenue will change if we change price. And you will see that this answer is actually related to the price elasticity of demand. Okay, oops. Okay, great. So first, let's see a very simple example of total revenue, right? You can see that here you have this demand curve, and on this dot, you can see that we have the price of 4, and we have the quantity of 100, right? So basically, you can see that the total revenue equals price of 4 times quantity of 100. So total revenue is 400. Right? So it's very simple. And graphically, you can see that if you're given this point, right, the total revenue is essentially given by the area of this rectangle, right? So this guy here, this area basically tells you what is the total revenue. In the future, you will see that this kind of graphical analysis will be helpful. Now, as I said, we want to understand how total revenue will change if we change price. So here we have basically two cases. The first case, we have inelastic demand. The second case, we have elastic demand. So here you can see that in the first case, let's say our starting point is this, right? So we basically move up. That is, we're increasing our price from 4 to 5. And on the right hand side, it's the same, right? We're increasing our price from 4 to 5. And obviously, when you change price, you will observe a movement along the curve. So you can see that the initial point would be this, and the point will end at here, right? So as we change price, you can see that in the left hand side, the quantity decreases from 100 to 90. And on the right hand side, for the same change of price, the quantity decreases from 100 to 70. Now let's do some calculation and see how revenue will change, right? This is a very easy calculation. So let's calculate the total revenue here. Well, it is very easy, right? It's 4 times 100, which is 400. And here, the total revenue equals 5 times 90. So it's 450. And then we will do the same for this graph on the right hand side. So here total revenue equals 4 times 400. Here total revenue equals 5 times 70, which is 350. Now, what you can see here is as we increase price, right, on this left hand side, the total revenue also increases. To be more precise, the change in total revenue equals 50, right? Here I'm using the sign delta. So delta total revenue means the change in total revenue. So basically delta means change. And here we have the same change, right? Price increases by 1. Now, we will observe the opposite movement in total revenue here, right? The total revenue actually decreases. So the change in total revenue is minus 50, right? So this is an interesting result, right? We're doing the same changes in the price. However, you can see that as we increase price, the total revenue could actually increase or decrease, right? So this is a very interesting observation. Now, let's see why do we have this result, right? So okay, maybe it's better for me to go back to this picture here. So why do we have this result? If you look at these colored rectangles, right? If you look at this guy, right? If you look at B and A, what you can see here is as you increase price, B, or the area of B, represents the loss, right? Because if you increase the price, then quantity decreases from 100 to 90, right? So it basically means we have to lose area B, right? So we have to lose B here. However, as we lose B, we will actually have A here, right? So we will actually, okay, let me use minus sign and the plus sign. So we will lose B, but we will have A, right? But you can see here, the area of A is actually larger than B. So this implies our gain is actually larger than loss. So the total revenue actually increases. Now, if you look at the picture on this right-hand side, you can see here, okay, this is the proportion we have to lose, right? Again, this is our loss or our reduction in total revenue. And we will gain this portion, right? So A is what we would gain if we increase our price. Now here you can see that A is smaller than B, right? So the total revenue will actually decrease. So let me write it here. So for this left-hand side, A is larger than B. This implies total revenue increases. And on this right-hand side, A is smaller than B. This implies total revenue decreases. Okay, that's great. Now we could go one step deeper to understand this result. If you look at these two demand curves, now we shift our focus to demand curve. What you can see here is this demand curve is, this guy is steeper, right? Compared. Okay, so this demand curve on this left-hand side is steeper. And the demand curve on the right-hand side is actually flatter. If you recall what we have learned in the previous class, we know that if a curve is steeper, then it actually have what? Smaller elasticity, right? So it's let's call this as inelastic. And we know that if a demand curve is flatter, then it has actually larger elasticity. So let's call this as elastic, right? So basically you will see a very interesting result. That is, if a demand curve is inelastic, right? Increase in price will increase your total revenue. And if a demand curve is elastic, the increase in your price will actually decrease your total revenue, right? So that's the basic result about how total revenue changes when you change your price. And this really depends on whether your demand curve is elastic or inelastic, right? So let me summarize here. So this slide gives you a very nice summary. So let me read it. Basically, if demand is inelastic, right? It is inelastic. That is, if the price elasticity of demand is less than 1, then price and total revenue move in the same direction. So this basically says, if you increase price, you will increase total revenue. Similarly, if you decrease price, you will decrease total revenue. Right? Now, the second point says, if demand is inelastic, mathematically this implies the price elasticity is actually larger than 1. So price and total revenue will move in opposite directions. This basically means if you increase your price, then your total revenue will suffer. And if you decrease your price, your total revenue will actually increase. So, okay, the third case is a very special case. So if the demand is unit inelastic, which means the price elasticity is exactly 1. In this case, total revenue will be the same as you change your price. Now, let's think about this. Why do we get this result, right? Why? Right? Why when demand is inelastic, your total revenue will be larger if you increase your price, right? That's the question here. Intuitively, you can think about how, or intuitively, you can answer this question according to the definition of elasticity. So let's say your demand is inelastic. This implies that even if you increase your price, your quantity demanded will only decrease a little bit because the demand is inelastic, right? So this basically means you could have, or you could sell your products at a higher price, but the quantity demanded will barely change. So this basically implies you will have larger, higher total revenue. Now think about the case when the demand is elastic. Now you can see that when the demand is elastic, as you increase your price, quantity will decrease by a large amount. So this means even if you're selling a higher price, but you're selling at but you can only sell much smaller quantity. So your total revenue will still suffer despite of higher price. Right? Okay. Now, let's examine how elasticity will change as we move along a linear demand curve. So let me repeat the question. The question here is, if we have a demand curve, right? So this is a demand curve. As we move along the curve, that is, let's say we move upward, that is, we increase price. We want to ask, as we increase price, how elasticity will change, right? The first thing is, we know that if for a straight line, it has a constant slope, right? Basically, it means that slope at point A equals the slope at point B. But now I want to ask you, will we have the same elasticities at point A and point B? Well, the answer is no, right? Even if point A and B have the same slope, they will have different elasticities. Mathematically, it's simple to show this, but intuitively, you can see that when you're defining slope is defined by rise over run, or the ratio of changes in y versus in x. But elasticity is the ratio of percentage change. Obviously, the ratio of change is different from the ratio of percentage change. So basically, even if A and B have the same slopes, then they should have different elasticities. Okay, to examine how elasticity will change as we move along a linear demand curve. So basically, let's use this simple example. So here, what you can see here is we have a demand curve, right? These two columns give you a demand curve, right? And given price and quantity, we can obviously find out total revenue, right? For example, this guy, 20, it basically equals 5 times 4. And we could also calculate elasticity at each price, right? At each price quantity pair. To get this, we have to first calculate the percentage change in price, right? So let's say we wanted to get this number, a elasticity of 1.8 at price 3 and quantity 4, right? That's our purpose here. So by the definition of elasticity, it is basically the ratio of percentage change in quantity divided by the percentage change in price. So we have to first find out what's the percentage change in quantity and the percentage change in price. And here we have the percentage change in price, which is 22%, right? So how do you get this number? Well, basically you can see that the price here is 5, right? So how do you get this 22%? So let's say we are increasing our price. In this case, we are basically looking at 4 and 5. So the change in price is given by 5 minus 4 divided by the middle point, which is 22%, right? For quantity, we are looking at these two numbers. So we have 2 divided by the middle point of 4 and 6, which is 5. So this gives us 40%. And to get the elasticity, it's essentially the percentage change in quantity divided by the percentage change in price, right? This gives us 1.8. You can see here that because the elasticity is larger than 1, so basically the demand curve at this point is elastic, right? Okay, let me remove these calculations and let's focus on revenue and elasticity. So our focus now is this column, right? Oops. So our focus now is this column and this column and this column. Now, let's see what's our observation on how total revenue changes if we increase price. So you can see that as we increase price, right, total revenue actually first increases, right? So until to this this value, total revenue increases. But after getting $24, total revenue actually decreases, right? So basically the first increase and then it decrease, right? And if we look how elasticity change, we will see that first the demand curve is inelastic and then it becomes elastic, right? And of course, between inelastic and elastic, we have this unit elastic. Now, what can you see here is actually quite interesting, right? So if you look at this part, they're inelastic, and if you look at these numbers, they're increasing as you increase price, right? This is exactly what we have learned. That is, if the demand is inelastic, increasing price will increase your total revenue. And if you look at this unit elastic case, and if you look at these two numbers, right, it basically shows that when the demand is unit elastic, as you increase price from 3 to 4, total revenue stays at $24. Again, we have learned about this. Total revenue stays the same if the demand curve is unit elastic, even if you increase your price, right? Now let's look at the third case. So we look at these three cases and these three numbers. What you see here is the demand curve is elastic, and we can see that as we increase our price, the total revenue actually decreases, right? Again, this result fits what we have learned, right? Okay, that's great. This picture is really a graphical representation of how elasticity changes as you move along the demand curve, right? So what you see here is on this part, when price is low, demand is inelastic, right? So we have inelastic demand. And for this portion, when price is high, right, we have elastic demand. And we have a special case, which is here, right? This is unit elastic, right? So how do you make sense of this result? Well, I could give you a simple intuition. So basically you can see that when price is low, consumers are not very sensitive to price changes. So the demand curve is inelastic. When price becomes high, consumers become very responsive, very sensitive to price changes. So in this case, you can see that if price is already high, continually increasing the price will actually reduce quantity demanded by a large amount. So basically, in this case, you can see that consumers are very sensitive to price, so you will have a high elasticity. Okay, let's learn about several other demand elasticities. So basically, in the first part of this lecture, we focused on price elasticity of demand. We could also talk about income elasticity of demand, right? So here we focus on how income affects demand. Mathematically, to calculate the income elasticity of demand, what we could do is basically we could use the percentage change in quantity demanded divided by the percentage change in income. Right? For example, if you're looking at this ice cream market example, if you find out a 10% increase in income increases the quantity demanded by 20%, then you would know that the income elasticity of demand is given by 20% divided by 10%, which is 2. Importantly, I want to emphasize here is you have to pay attention to the sign of the income elasticity of demand. So here you can see that ice cream is basically a normal good, right? Because you can see that if you increase income, quantity demanded increases. So you will get a positive number of income elasticity of demand. However, if you have an inferior good, then increasing income means decreasing quantity demanded. So the income elasticity of demand for a inferior good will be negative, right? So the sign is important because it tells us whether this consumption good is inferior or normal. This is different from price elasticity, right? We always want, or by convention, we always want the price elasticity to be positive, right? Even in fact it is negative. And for income elasticity, you cannot do this. You cannot force income elasticity of demand to be positive because the sign of this income elasticity tells us some information, tells us whether this consumption good is inferior or normal, right? So you have to be careful when you're calculating income elasticity. The third one is about cross-price elasticity of demand. So this is a measure, right? This is a measure which tells you how much the quantity demanded of one good will change if there is a change in the price of a different good, right? So basically you can see the formula here. The cross-price elasticity of demand equals percentage change in quantity demanded of consumption 1 divided by the percentage change in the price of consumption 2, right? So this is still a price elasticity, but it's a cross-price elasticity. It's a cross-price elasticity because you're thinking about two different consumption goods, right? Okay, now let's see this example here. Let's say, again, we're looking at this ice cream market example, and we find out a 10% increase in yogurt price increases the quantity demanded of ice cream by 15%. So in this case, you can see that the cross-price elasticity is 1.5. Again, importantly, the sign of cross-price elasticity tells us some information. So you can see that here we are having a positive cross-price elasticity. Why do we have positive cross-price elasticity? Well, because yogurt and ice cream, they're substitutes. On the contrary, if we have complements, then their cross-price elasticity of demand should be negative, right? Again, this is different from the pure price elasticity. For cross-price elasticity, you have to pay attention to the sign, right? The sign tells us information, tells us whether we are dealing with complements or substitutes. Okay. Okay. This quick quiz is very simple, right? It says, define the price elasticity of demand. Well, this is easy, right? It's just the percentage change of quantity divided by the percentage change of price. Explain the relationship between total revenue and the price elasticity of demand. Well, we have learned about this, so let's review this result. So basically, we know that if price increases, right, then we know that total revenue increases if we are having inelastic demand, and the total revenue decreases if we are having elastic demand, right? So that's the basic result here. Okay. Now let's talk about the elasticity of supply. Well, since we have talked about the elasticity of demand, so the elasticity of supply is actually pretty easy to understand. So basically, price elasticity of demand measures how much quantity supplied would change if there is a change in the price of the product. So mathematically, you can see here the price elasticity of demand, the price elasticity of supply equals the percentage change in quantity supplied divided by the percentage change in price. For example, let's say if the price of milk increases from 2.85 to 3.81, and the quantity supplied increases from 9,000 to 11,000. Let's calculate the price elasticity of supply. So we know that price elasticity of supply equals the percentage change in quantity divided by the percentage change in price. Now here, when you're calculating percentage changes, you still want to use the middle point method, right? So the percentage change in quantity is given by 2,000 divided by the middle point, which is 10,000. And the price change is 0.3 divided by the middle point, which is, I believe it's 3. Right? So this gives us 2. So the price elasticity of supply is 2 here. Okay, just like demand curve, we could talk about the elasticity of supply according to whether the elasticity is larger or smaller than 1. So a supply curve is elastic if the elasticity is larger than 1, right? So basically you can see that in this case, the quantity supplied is very responsive, is very sensitive to price change, right? To be more precise, the quantity supplied moves proportionally more than the price. And supply is inelastic if the elasticity is less than 1. In this case, quantity supplied moves proportionally less than the price. And supply will have unit elasticity if the elasticity is exactly 1. So quantity supplied moves the same amount proportionally as price. Okay. Now let's ask, what determines price elasticity, right? Here we will only talk about one major factor. Here, the key determinant of price elasticity of supply is the time period, right? It's the time period. So basically, you can imagine that if you're a producer, your supply will be more responsive to price changes in the long run, right? Well, because if you see a price increase, potentially, let's say you want to increase your production. However, increasing production needs time, right? You have to make some adjustments, maybe to your factory or buy more machines. In this case, it could take you several months or even more than 1 year to increase your production, right? So that's why price elasticity of supply is larger in the long run or in a longer time. Okay, let's see how could we calculate the price elasticity of supply, and let's also see how the slope of the supply curve is related to the price elasticity of supply. So let's see the first picture, right? In the first picture, PS equals percentage quantity divided by percentage price. Well, this is a vertical supply curve. The implication is there is no change in quantity. So it's 0 divided by price change. So this gives us 0, right? Very easy to calculate. Now, what about the second one? Well, the second one is the change in quantity, which is given by 1 divided by 4.5, and the percentage change in price, which is, obviously I made a mistake. So the quantity is 10 divided by the middle point, which is 60. And the price change is 1 divided by the middle point, which is 4.5. So this gives us 10 divided by 20, right? Now what about this one? Again, this is 25 divided by, I think it's 112.5, right? Divided by the percentage change in price. So it's 1 divided by 4.5. This gives us 1. Okay, I will skip the fourth one. Basically, you have the formula here. So the PS is 67 divided by 2, which is larger than 1. What about this case? Well, this is a special case. You can see that it's a flat curve. So basically, the percentage change in price is 0. It's Q divided by 0, which gives us infinity. Right? Okay, great. Now let's see what kind of lesson we can get from these different pictures. So here you can see that for this vertical curve, its price elasticity is very small. It's just a 0. And then for this steep curve, right, this is quite steep. So we have a price elasticity of less than 1. And then we have a flatter curve. Then its price elasticity is 1. Then we have a even flatter, right, curve. In this case, its price elasticity is actually larger than 1. And for this last case, it's horizontal. So it's like completely flat. Right? In this case, you can see that the price elasticity is actually infinity. It's infinity large, right? So what's the lesson here? The lesson here is, it means, or the conclusion is, generally, flatter supply curve is more elastic. So this is very similar to what we have learned about demand curve, right? demand curve, in the case of demand curve, we know that a flatter demand curve is more elastic. So to summarize, we could say that generally, a flat demand curve and a flatter supply curve, they're more elastic, right? Where you could even say a flatter curve is more elastic. Okay. So previously we learned about how the price elasticity of demand changes as we move along the demand curve, right? And we could also talk about the same topic about the supply curve. So here you can see that as we increase our price, as we move along, right? As we move along this supply curve, in the beginning, the elasticity is large, which is larger than 1. And as we continue to increase our price, the elasticity will become small, which is less than 1, right? So why do we get this result? There are two ways to understand this. The first one is simple. You would just look at the shape of these curves, right? Now what you can see here is, for this portion, it's very flat. And we know that flatter curves are more elastic. So that's why you have a large elasticity at this part. And now if we look at this portion, it's very steep. And we know that steep curves, they have small elasticity. So that's why you have small elasticity here. The second way to understand this is through economics. So basically, when your production level is low, right? Let's say your production level is here. Let's say your production level is here. Then generally, you have some redundant capacity. This means at a low level, at a low production level, if you observe a price increase, you could quickly increase your production. So quantity supplied can be very responsive to price changes. So your elasticity at this low production level will be large. And now, if you're here, right? Your production level is already high. This implies your factory is running at its full capacity. So now, if you see a price increase, even if you want to increase your production level, due to this capacity constraint, it will be hard for you to actually increase your production level. At least you might need to wait for several months to buy new machines, to expand your factory size, to increase your production. So that's why at high level of production, your price elasticity of supply is low. Okay, let's see this question here. Assume the supply of beachfront property is inelastic and the supply of new cars is elastic. Suppose population growth causes demand for both goods to double. For which product will P change the most? For which product will Q change the most? Okay, now let's see how could we solve this. So we have two markets. The first is the market for beachfront property, and the second is the market for cars. The first market is inelastic. The supply curve for the first market is inelastic, and the supply curve for the second market is elastic. So what we're gonna do is we will use this supply and demand curve, and we will look for how market equilibrium change. So let's first discuss. Oops, I have to find some space to solve this. Yeah, maybe I'll use. Okay. Now let's first discuss beachfront houses. Right. So let's draw the demand curve like this, and let's draw the supply curve for beachfront houses. Okay, let me use a different color. So let's say this is for beachfront houses. And now let's draw the supply curve for new cars. Oops, what happened? Oh, okay, for new cars. Let's see, how could we draw the new cars? Let's say the supply curve of new cars looks like this. So this is for new cars. The important thing here is you should say that the supply curve for new cars is flatter compared with the supply curve for the beachfront houses. The reason is we have learned beachfront property. Sorry, the supply curve for beachfront property is inelastic. So we want the supply curve for beachfront houses to be steep. And if the supply for new cars is elastic, then we want the supply curve for new cars to be flat. Okay, great. Now let's see how should we shift the demand curve. Well, we know that the population growth will increase demand. So let's draw out this new demand curve. Right? So the demand curve will actually look like this. So this is the new demand curve, D prime. And the original demand curve is just a D. Now, let's see what's the question here. It says, to which product will price change the most? Well, you can see that it's easy, right? So we're basically starting from the sort of the same equilibrium. For beach house, the equilibrium would be here, given by the red dot. And for new cars, the equilibrium is given by this green dot. So you can see that the price change in the the price change for this red dot is actually larger, right? So the answer is for beachfront. Oops. For beachfront, price change will be the most. What about quantity? Well, you can see that the quantity changes is actually larger for this new car market, for this green dot, right? So the answer is for quantity, the new car, right, will actually change more. Okay. A quick quiz. Define the price elasticity of supply. Well, it's just quantity supplied divided by the price elasticity of supply is defined by the percentage change in quantity supplied divided by the percentage change in the price. Explain why the price elasticity of supply might be different in the long run than in the short run. Well, because in the long run, firms, they could have more time to adjust their production, right? So in the long run, the quantity supplied will respond more to price changes. So that's why the price elasticity of supply will be larger in the long run than in the short run. Okay, let's talk about three applications of supply, demand, and elasticity. These are actually really interesting applications. And sometimes you will see that the result you get from these applications could be surprising. So it's quite interesting. Okay, let's talk about the first application. So the question is, can good news for farming to be bad news for farmers? Right. So let's see this example here. Let's say University of Winnipeg scientists discovered a wheat which produces 20% more per acre of farmland. Will farmers at Manitoba benefit? So basically here you can see that it's like we're having better technology in producing wheat, right? So the question is, will farmers be better off because of this better technology? So what we will do here is we will analyze how demand curve and the supply curve will change. And we will see how market equilibrium change. And more importantly, we will use what we have learned about elasticity to think about how total revenue will change. Okay, so let me first draw out the demand curve and the supply curve. Now first, which curve should we move, right? Which curve should we shift? Well, you can see that here we are having better technology. And we know that this should shift our supply curve. To be more specific, supply should increase because of better technology, right? So we should shift the supply curve to the right. So this is the new supply curve, S prime. Now, let's see how should market equilibrium change. So basically, the market equilibrium will change from the black dot to the red dot, right? What you can observe here is, after this better technology, price will decrease, right? Now, if price decreases, will this reduction or the decrease in price hurt farmers or benefit farmers, right? So basically we can see price decrease, quantity increase. So how farmers will feel about this kind of change? Well, we could think about this from the perspective of total revenue. So we want to ask whether total revenue to the farmers will increase or decrease. What is your answer? Well, you have to use elasticity, right? So the argument here is the demand curve for wheat is inelastic. Why it is inelastic? Well, because wheat can be considered as a necessity. So generally, demand curve for necessities is inelastic, right? So basically, in this wheat case, demand curve for wheat is inelastic. This implies as you decrease price, total revenue will also decrease, right? So basically, the answer here is total revenue will decrease because demand curve is likely to be inelastic, right? Obviously, you have to remember the result we just discussed. That is, if a demand curve is inelastic, then price and total revenue, they would move in the same direction. That is, higher price, higher total revenue. Lower price, lower total revenue. Now you have this textbook graph here. So basically you can see that you're having a pair of numbers, right? A pair of price and quantities. So at this original equilibrium, total revenue is, let me see, what is the total revenue? It's 3 times 100, 300. And here, total revenue becomes 220, right? Okay, now let's see the second application. Why did the Organization of the Petroleum Exporting Countries fail to keep the price of oil high? So basically, OPEC restricted oil production and raised the oil price during 1970s. And after this restriction, oil price actually increased a lot. But in 1980s, oil price actually decreased. So OPEC actually failed to maintain the high oil price during the 1980s. So let's see why. Okay, now let's first draw out supply and demand curve. Right? This is quantity, this is price. So let's assume this is about 1970s. And in 1970s, OPEC restricted oil production. This should decrease supply, which means the new supply curve should be on the left. So this is S prime. Now what you see here is the price should increase, right? So at the new price, at the new equilibrium, we get a price P prime. Let's call this as, let's say the price at the original equilibrium is P. So obviously P prime is larger than P. Now let's see what would happen in 1980s. Now importantly, in 1980s, what you observe is we will have flatter demand curves and flatter supply curves. And in this case, even if you decrease your supply, your oil supply, the change in price will actually be small. So again, you can see that in 1980s, we still could observe this higher price. However, the change in price is much smaller. Okay, I don't think I am doing a great job in drawing out these two different cases. So I will so let's look at the textbook drawings, right? They're much better. So here you can see that we get steeper supply curve and demand curve, right? In the short run, that is in the 1970s. And in the long run, that is in the 1980s, after 10 years, the demand curve will become flatter and both supply curve will become flatter. And in this case, you can see that the difference in price here is very small, right? So the question is, why demand curve and supply curve would become flatter in the long run? Well, we have learned that elasticity is larger for both demand and supply in the long run. And we also learned demand curve and supply curve will be flatter if they have larger elasticity. So this implies that supply curve and the demand curve will become flatter in the long run, right? Okay, that's great. Let's talk about the third application. So the third application is about drug interdiction. So basically the word interdiction could be exchanged for prevention, right? So it's about drug prevention. So our question is, does drug prevention increase or decrease drug-related crimes? The story is like this. So to discourage the use of illegal drugs, the Canadian government, they would spend millions of dollars each year to reduce the flow of drugs into Canada. So this is basically the first approach to prevent drug abuse. And there is also this second approach, right? We could also use education, right? We could educate people, right? And tell them the negative effects of using drug and how to prevent the drug and how to quit drug, right? So now our purpose is we want to compare these two policies. That is, we wanted to compare the drug interdiction versus drug education. We want to see whether the drug interdiction will increase or decrease drug-related crimes. Okay, I will just use the textbook pictures because they're nicer. So on this left-hand side, we're having this drug interdiction. So here, what you can see here is because of interdiction, this basically reduces the supply of drug in the market. So you can see that through drug interdiction, supply curve should shift to the left, right? And what you observe here is the equilibrium point shifts from this black dot to this green dot, right? Okay, let's look at the drug education. So drug education is a demand shock. Through drug education, if it is effective, then there should be a decrease in the demand, so which implies we should shift demand curve to the left. So again, the market equilibrium goes from the black dot to this green dot. Now, let's see how price will change, right? So here we can see that importantly, for this case, for this drug interdiction case, we can see that price will increase, right? Now, if drug price increases, should the total revenue from selling drugs increases or decrease? Well, the answer is if price increases, the total revenue of selling drug increases. The reason is because the demand curve for drug should be inelastic. Why? Well, because we're talking about drugs. If you're getting addicted to drugs, then you will do drugs no matter what is the drug price. This implies the demand curve for drug is very inelastic. And we have learned for inelastic demand, total revenue increases as we increase price. So that's why we get this result here. Now, think about what happens if total revenue from selling drugs increases. This basically implies that people doing drugs will have to spend more money, right? So this basically implies that to obtain more money for drugs, there would be more drug-related crimes committed by these drug addicts, right? So the conclusion here is drug interdiction will increase drug price, reduce drug consumption. However, it could potentially increase drug-related crimes because the drug would become so much more expensive. And now if you look at drug education, you can see that it will reduce both price and consumption. And in this case, you can see obviously the total revenue from selling drugs will be lower. So basically, in this case, the drug-related crimes should be lower, right? So this is somewhat a surprising result. And you can see that the supply and demand curve analysis and elasticity, these are very powerful tools, right? Just through these very simple process, very simple pictures, you could actually answer some important policy questions. Okay, let's look at this quick quiz. How might a drought that destroys half of all farm crops be good for farmers? If such a drought is good for farmers, why don't farmers destroy their own crops in the absence of a drought? Okay, first, let's think which curve should we shift, right? Obviously, here you can see that if there's a drought, then there should be a decrease in supply, which means we should shift the supply curve. Right? So, okay, let me first draw out these curves. So we should basically reduce supply curve. So this is S prime, which is the shifted supply curve. Why this could be a good thing for farmers? Well, the analysis here is quite similar to the first example. In the beginning, equilibrium is here, given by this black dot. And after shifting the supply curve, equilibrium is given by this red dot. So what you can see here is price increases, right? Now, we're back to the first example because we're talking about demand curve for food, right? So you can see that the demand curve is inelastic. And if the demand curve for farmers' products is inelastic, then this basically implies that as price increases, total revenue increases, right? So that's why from the perspective of a farmer, a drought is a good thing because higher price implies higher total revenue. Okay, let's look at the second question. If such a drought is good for farmers, why don't farmers destroy their own crops in the absence of a drought? This is not like a economic question. Well, basically, as a farmer, right, you want a drought, but you only want a drought for others, right? So if there is a drought for other farmers, then the total supply for this for farmers' products will be lower, and your farming products will sell at a higher price. You will get higher total revenue. However, you will never want to destroy your own crops, because by destroying your own crops, you have nothing to sell, even if the market price is higher. I mean, basically the answer is you would wish other farmers to destroy their crops, but you would want to keep your crops. Because if other farmers destroy their crops, then the price will be higher. And if you keep your crops, you could sell your crops at a higher price. Right? So that's why you don't want to destroy your own crops. Okay, yeah, maybe I could start several true-false questions. I think I have like 3 minutes left. Okay, let me see if I could find. Okay, maybe I could finish the first one. It says the demand for gas will respond more to a change in price over a period of 5 weeks than over a period of 5 years. Well, if you look at this, you can see that this is incorrect, because 5 weeks, right? 5 weeks is actually a shorter term, is a shorter time compared with 5 years. And we know that no matter whether it's a demand curve or a supply curve, right? The curve will respond more to a change in price over a longer period of time. Okay, let's look at the second one. The price of calculators increases by 15% and the quantity demanded falls by 45%. The price elasticity is 3. Well, this is actually right? Because the price elasticity is defined by the percentage change in quantity demanded by the percentage change in price. So 45 divided by 15 gives you 3. So this one is correct. Now the third problem. The middle point method is used to calculate elasticity between 2 points because it gives the same answer regardless of the direction of the change. Well, this is right? This is exactly why you need middle point method. If you don't have middle point method, your answer will be different depending on what is your starting point. The flatter the demand curve, the more inelastic. It's not, right? The correct answer is the flatter the demand curve, the more elastic the demand, right? So this one is incorrect. If the price elasticity of demand is equal to 0, demand is unit elastic. Of course, it's not, because if the demand is unit elastic, then elasticity should be equal to 1, right? So this is incorrect. Okay, I will just finish 4 true-false problems so we could continue to solve the other problems in the next class.